Hey there, science fans! Today we're diving into the world of communication networks. Ever wondered how your voice travels across the globe in a phone call or how data zips through the internet? It's all thanks to some clever techniques called circuit switching and packet switching. Let's start with circuit switching. Imagine you're calling your friend across town. Circuit switching is like having a dedicated line set up just for your conversation. No one else can use it until you hang up. Before you even say hello, a physical path is established between your phone and your friend's phone. This path, or circuit, is reserved exclusively for your call. Think of it like laying down a train track directly from your house to your friend's house. Your voice travels along this track as electrical signals. Pretty cool, right? Let's break down how circuit switching works when you place a phone call. First, call setup. You pick up the phone and dial your friend's number. The network then springs into action, finding an available circuit between your phone and theirs. This process is like reserving that dedicated train track. Next, data transfer. Once the circuit is established, your voice is converted into electrical signals and transmitted over the dedicated line. These signals travel at lightning speed, ensuring you can have a real-time conversation. Finally, teardown. When you're finished chatting, you hang up the phone. This signals the network to dismantle the circuit, freeing it up for other calls. It's like taking down the train track after your journey. Circuit switching is all about creating a direct and uninterrupted connection for the duration of your communication. It's reliable and predictable, just like a train running on time. Like any good scientific method, circuit switching has its pros and cons. Let's explore them. Advantages: first, guaranteed data order. Just like a train arriving in the order of its carriages, data in circuit switching arrives in the same sequence it was sent. This is crucial for real-time communication, ensuring your voice doesn't sound all jumbled up. Second, low latency. Remember that dedicated line? It means low latency, which is the delay before data transfer begins. This makes circuit switching ideal for applications where speed is key, like video conferencing or online gaming. Third, dedicated bandwidth. With a dedicated circuit, you have a fixed bandwidth allocated to your communication. It's like having a whole train track just for yourself, ensuring consistent performance. Disadvantages: first, idle bandwidth. While you have a dedicated line, you might not always use all the bandwidth. It's like having an empty train carriage, a waste of resources. Second, setup time. Establishing a circuit takes time, which can be a drawback for short bursts of communication. Third, vulnerable to path failure. If a single link in the circuit fails, the entire connection drops. Imagine a broken track, your train can't get through. Section 4, exploring packet switching. Data on the move. Now let's switch tracks, pun intended, and explore packet switching. Instead of a dedicated line, packet switching breaks your data into small packets, each with its own address label. Think of sending a letter. You wouldn't rent an entire truck for one envelope, right? Packet switching is similar. It's like sending your letter in pieces, each labeled with the destination address. These packets travel independently across the network like individual travelers finding their way. Don't worry though, at the destination, these packets are reassembled in the correct order to reconstruct the original message. Section 5. Packet switching in action, sending an email. Imagine sending an email using packet switching. First, packetization. Your email is broken down into small data packets, each with a header containing the source and destination addresses like an envelope. Second, transmission. Each packet travels independently across the network, choosing the most efficient route available at that moment. It's like each packet hopping on different trains and buses to reach the destination. Third, reassembly. Once all the packets arrive at the recipient's end, they are reassembled in the correct order based on their header information, like putting the pieces of a puzzle back together. Packet switching is all about efficiency and flexibility, making the most of network resources. Section 6. Advantages and disadvantages of packet switching. Just like circuit switching, packet switching has its own set of advantages and disadvantages. Advantages: efficient bandwidth use. Since multiple users share the network, bandwidth is used more efficiently. It's like having a bus carrying many passengers instead of each passenger having their own car. Rerouting capability. If a path becomes congested or fails, packets can be dynamically rerouted. ensuring reliable data delivery. This is like finding an alternate route if there's traffic on your way. Handles high-volume data. Packet switching can handle large volumes of data from various sources simultaneously, making it suitable for the internet's vast scale. Disadvantages: packet reordering. Packets might arrive out of order, requiring reassembly at the destination. It's like receiving puzzle pieces in a random order. Delays or latency. Packet switching can introduce latency, especially during network congestion. Imagine a traffic jam on the internet highway. Additional resources. Handling packets adds complexity and requires additional resources for routing and reassembly.